All right, welcome. So we're about to start. So I'll be quick on this particular one, kind of a summary lesson. I want to teach actually. So today we want to talk about atomic structure. Now, my area of focus on this particular topic is basically on what we call the subatomic particles. Subatomic particles. Stay with me. I'm going to simplify everything. I'm going to be doing a lot of repetition to make sure that everybody is carried along. Everyone here is carried along. So I want to focus on hi, you're welcome. Thank you for joining us today. My name is Instructor Allison. Good evening to you. Good evening. Welcome. Thank you for joining my live stream. I'm happy to have you guys here. So I believe you're going to stay with me till we'll be able to complete today's tasks because we'll be doing a lot on chemistry. We'll also be doing a lot in physics and mathematics, depending on your strength and your energy in supporting the live stream, sharing the live stream, and also sending us love. So thank you so much for joining us. Good evening and welcome. So today we'll be focusing on subatomic particles in an atom under this topic called the atomic structure. Now, there are three main subatomic particles found in an atom. I'm going to write that down so that it's going to be key point. If you're struggling to understand this topic, this will be key point for you because I'll be going straight to the point. So take note of this. I said there are three main subatomic particles found in an atom. So I'm writing every bit of important statement I'm making so it makes everything easier for you. So have your notebook and make sure you're putting these things down. You're welcome, guys. Thank you for joining us. So I will show you the particles. There are three things I'll be showing you. Watch. I'll be showing you the particles. I'll also be showing you guys their charges, and also I'll be showing you guys their relative mass. You can call it relative atomic mass as the case may be. And then lastly, I'll also show you where they are located. So these are the things I'm going to be covering right now. So let's go ahead. So now let's use a tabular form to make this look so easy for us. If I ask you what are the three subatomic particles, can anyone tell me in the comment section what are the three subatomic particles? If you have idea about it, please start talking. Start talking. I want this class to be engaging. If you are asked what are the three subatomic particles, do you have idea about that? Good evening, tutor. Listen, you're welcome. Please, if you have the answer to the question, do that right now. But if you don't understand it, if you don't know it, no problem. That's why I'm here. So this is going to be the particle. This is going to be the particle. I think somebody is saying something in the comment section. Somebody is saying something in the comment section. Yeah, he said electron, neutron, and proton. That is smart. That is smart. That is smart. So we're going to look at these particles. We're going to look at the charges, the relative mass. That's why I'm putting in a tabular form real quick. This will make you remember these things easily. So please remember that the particles are, the first one is proton. I'm not naming them in a particular order. That's to just make this thing easier. The next one is electron, and the next one is neutron. In case you don't remember these things, please, this should be the last time you forget this thing. These are the particles. If they ask you what are the subatomic particles in an atom, tell them proton, electron, and neutron. Is that clear? Is that clear? Thank you guys for joining our live stream. You're welcome. Is that clear? Awesome. So if they ask you what is the charge of this proton, is proton having a positive charge, or do proton have a negative charge, or do proton have a neutral charge? What do you think is the answer to that? What is the charge for proton? What is the charge for proton? Positive. That is awesome. So proton has positive charge, and electron has a negative charge. Obviously, since proton and electron has taken positive and negative charge, obviously you know that neutron goes for neutral. It has a neutral charge, Now, a very quick one. What do you think is the relative mass of proton? It is 1. If you can remember that proton and neutron, these are the two guys that are seated in the nucleus of an atom. In the nucleus of an atom, I'm going to draw a circle where I'm going to demonstrate this. In the nucleus of an atom, proton and neutron, they are always in the nucleus of an atom. Proton and neutron. Electrons moves around the nucleus, around the orbit. So any charge that proton has is the same charge neutron will have. So if the relative mass of, the mass, if the relative mass of proton is 1, similarly the relative mass of neutron is also going to be 1. Then what is the relative mass of electron? It's very small. It's quite lesser than this particular one. It's about 1 divided by, is it 1840? Thereabout. Can't still remember. I think it's around this. Because if it's very small, it's quite very small. If you divide this particular number, you should be having a lot of zero, like 0.000543, and as the case may be. Very, very small. Less than this particular relative mass of proton and neutron. Are you catching the flow? Are you catching the flow? Are you understanding the lesson? Is it making sense? So the next question is that, where is proton located? Where is the location of proton? Of course, that thing in your mind might be correct. Proton is located in the nucleus. I just said it a few minutes ago. In the nucleus of an atom. Similarly, the same place neutron also stays, in the nucleus of an atom. Then where does electron stays? Who can tell me? Where does electron stays? Where is the location of electron? If proton is located in the nucleus, electron is also, proton is located in the nucleus, neutron is also located in the nucleus. Where is the location of this particular electron? Somebody said energy level, somebody said octets. I guess the person that said, somebody said outermost shell. I think the best name we should give it to it is orbital. Your answers might be correct, but the best word we should give to it is orbital. It makes it look so much matured and interested. Somebody will say energy level, makes a lot of sense. Outermost shell makes sense. But when you call orbital, it covers it. It makes it look very, very easy. Are you following? Are you following? Now, so this is what I intend to cover on this particular one. Let's close down on this particular one. What is the next thing? I have mentioned some keywords that a lot of students may not be familiar with. Let me explain that very quick. What are the keywords that I have explained? The first one I mentioned is orbital. Orbital might be a term that a lot of students may not know what that means. Let me quickly tell you. Now, when you see orbital, just know that this orbital is a region. Orbital is a region in space, where there is a high possibility of finding an electron. So if they ask you a region in a space where there is high, place emphasis on high possibility, emphasis on high. A region in a space where there is high possibility. Okay, somebody said your favorite memory. I don't know what that is. Maybe it's a mistake. I don't know. So, okay, so just pay attention to this particular one. A region in space where there is pay attention to high possibility of finding an electron is what we refer to as orbital. Now, if we now ask you a question, what about the region in a space where there is low, this time is not high? What about if we have a region in a space, let me use another ink to differentiate this. A region in space where there is a low, a low, this time is not high, so emphasis on low, where there is a low possibility, a low possibility of finding an electron. What could be the name of this one? If the region in a space where there is high possibility of finding an electron is called orbital, then a region in a space where there is a low possibility of finding electron is called what? Hi, you're welcome. Thank you for joining us. It's called what? Do anyone have, somebody say proton or electron? No. Yes, somebody just mentioned it, but not completely. Nodal. Yeah, nodal plane. That's pretty interesting. Nodal plane. Nodal plane is a region. Nodal plane. Somebody is just learning this one for the first time. If you're that kind of person, then hit the thumbs up. Hit the thumbs up. If you're that person that just get to know this one or whether this one the first time, hit the thumbs up for me. Hit that and make sure to share this live, because if you check, we are just 42 persons. But if you just try and share this particular live to other students who are preparing for the exam, trust me, they're going to enjoy this lesson. They will not miss this lesson. Try and share the live. Thank you so much for your assistance. As I'm assisting you, try to assist me to, assist a lot of students, or assist me probably by sharing the live so that other students comes and learn. Okay, because they really need this lesson right now. Okay, so that's not that plane. Okay, now we just tracked two important points. A region in a space where there is high possibility of finding an electron is called orbital, and a region in a space where there is low possibility of finding an electron is called nodal plane. What about a region in a space? Let's do that last one. Let's do that last one. This is the third one. A region in a space. What about a region in space, a region in space where there is no possibility, no possibility. Emphasis now on no. Remember, the other one is region in a space where there is high possibility. This one, another one is region in space where there is low possibility. Another one is region in space where there is no possibility of finding an electron. What is that now called? Anyone has any idea? A region in a space where there is no possibility of finding electron. What is that called? Interesting. Nobody has idea. It is called forbidden state. Forbidden. It's called forbidden state. Forbidden state. And someone is just learning this for the first time. Others may have idea about it, but if you're that person who is just learning this for the first time, that means you didn't waste your time coming to my live stream today. Share this particular video, like this video, and make sure that you subscribe to the channel. Hit that subscribe button. Hit that subscribe button so that by the time I come live next time, you may receive notification. So now, basically, what we are saying is that this is an atom of, this is an atom consisting of a central nucleus. If we assume this to be an atom, if we assume this to be an atom containing the central nucleus, and then we have, say, this is the nucleus, and we have this one. We have probably, let me just stop it somewhere here. Good. So So I need you to understand that this particular one is the nucleus of an atom. This particular one is called the nucleus. It's called the nucleus. It's called the nucleus. The nucleus. It's called the nucleus of an atom. Inside this particular nucleus of an atom, we still have proton. We have the proton. Inside the nucleus of an atom, we have the proton. Inside this nucleus, we have the proton, and we have another one called the neutron. Inside the nucleus, we have the proton, and we have another one called the neutron. The neutron. Keep in mind that this neutron has no charge. No charge. No charge. Proton has a positive charge. And this is what we call the nucleus that houses the proton and the neutron. On this surface, you can have two electrons. These ones are what we call the electrons. The electrons are the ones you're having here. You can have more electrons if you want to, depending on the information you want to pass. Depending on the information you want to pass, you can have more electrons, and just like that. I've just told you where the electrons are located, where the proton is, and where the neutron is in the nucleus of an atom. All right, I don't want to do so much labeling and so much diagram and all of those things, just to pass the information. Okay, so are we catching the flow? Are we catching the flow? Now, remember, I told you it's more like a summary class, like a key point. So I'm not going to be giving you a lot of stories. I'm just going to be focusing on the areas you should be using. You probably will be using for your exams. Those are things I want to focus. So right now, what I want to do is to focus on another aspect of this particular class. The big question right now is, how does electron particles arrange? How, or let's say, let me show you how electron, how do we arrange? Somebody should ask me, or somebody could ask me, why do I have just two electrons here, and on this other part I'm having two, four, six, eight? Now what happened to this one? So that's what I want to show you. That's what I want to show you, and this will be useful in exam. How electron particles are arranged. How do we arrange these things? How electron particles are arranged in an orbital. How electron particles are arranged. Remember, say, I've been telling us, say, a region in the space where there is high possibility of finding electron, now it's in a core orbital. So how do we arrange electrons in this particular orbital? That is what I'm going to be showing you right now. If you've not hit the thumbs up, hit the thumbs up. If not hit the subscribe button, consider to take this time now. Take just 1 second of your time, hit the subscribe button if you've not done that before. Hit the subscribe button. Then the last thing, if you've not done, if you've not shared this live, please share. Consider, okay, I will pause right now. I will just pause for just 2 minutes for you to be able to share the live stream to your statuses, share the live stream to the group chat. If we have up to 100 persons learning with us, because we usually have more than 100 persons, a lot of persons are now aware I'm coming live today. Please, let's endeavor to share. I'm not seeing anybody sharing the live stream. Let's share to our group chat, share on Facebook, share on every of the platform to make sure people join us right now. I'm giving just 2 minutes for that. Good evening and good evening, welcome. I'm giving 2 minutes for that exercise. Please, let's do that real quick so that I continue the teaching. I do not really have much time. I have a lot of things I want to cover right now. So please, let's do that real quick. Everybody, please be involved in it. Please be involved in it. Everybody be involved in it. I asked you guys to share the live. You're telling me let's see the first page. Are you not supposed to join up in that exercise? Why are you people always acting like you don't care about the person who is teaching you guys? I'm doing this so that all students will be learning alongside. Why do you act like you don't care about it? This class is for free, and it's my time I'm bringing out to give out this information for free. So I say you should share the live so that other students who are not aware I'm live should come and learn with you guys to benefit. Please share not only on your status, group chat, share, because when people see students see and come here, they will not want to go. They will stay here and learn. I'm being certain about what I'm saying. So without further ado, let's continue. Whether I decide to listen to the instruction and share, and or whether I didn't share, that's up to you. But then I'll have to start. I'll have to continue from where I stopped. Please, if you've not screenshot this thing, please do that right now. If you've not snapped this thing, do that right now, because you don't have time for you to copy. Screenshot these informations. You need them. If you've not done that, do that right now. Thank you so much. Thank you so much. Thank you so much. If you actually have shared the live stream, thank you so much. Thank you. You guys are kind as well. All right, let's continue. How electron particles are arranged in an orbital is pretty simple. This is what I want to tell you. Please pay attention to this statement I want to make. Look at this statement I want to make. Please pay attention to it. There are there are three there are three chemical principles you need to learn. There are three chemical principles you need to be familiar with. There are three chemical principles that you need to know that governs that governs the arrangement that governs the arrangement of elements that governs the arrangement of elements in an orbital. In an orbital. So there are three chemical principles that governs the arrangement of elements in an orbital. Are you there? Somebody said it is not clear. Please, what is not clear exactly? Let us know, because we don't have time. Let's start striking these things back to back. I want to make sure that we use limited time, but we achieve a lot of things. What is not clear? Is it clear to you right now? Let me know in the comments. So the first chemical principle you need to be familiar with is what we call the half-ball principle. Half-ball principle. Half-balls principle. Please call it out. Everybody call it out. Half-ball principle. Call it out. Learn how to call this thing now. Call it half-ball principle. Have you done that? Have you done that? Half-ball principle. Okay, somebody said I should use pigeon. Should I switch to pigeon? Is the English not making you guys to understand? Should I use pigeon? You guys are not liking the English. If you're not seeing my handwriting, it's not my fault too. There's no way I can write somehow different. Like I don't know. That's that's I don't know how you want me to write. Like if you can't see my handwriting, I don't know what to do. Maybe someone should help you. Yeah, that's the best I can do. And I'm not even giving the my normal handwriting. I'm just doing the one students can see. So if you can't see it, it's not my fault anymore. So everybody pronounce this thing. Pronounce it out. I want to hear you call it out. Oh yeah, now talk and now call am out. Half ball principle. Everybody call am want to go. Half ball principle. Who is we are not seeing? Are you speaking for yourself or you're speaking for everybody? These people who are typing yes, yes, yes. Does it mean they are not also seeing the writing? Or is it everybody? Like I'm confused. When I talk now, and I know they see my handwriting. All right, there are three chemical principles. Okay, they say my handwriting is very perfect, so they can see it now. Let me continue. So the first principle you go sabi if you want to know how to arrange elements for this orbital, one now the one we call Havre principle. The second one, then they call them polys. Some people they call them poli. Some people call it polys. Polys exclusion. Poly exclusion. Some people they call them polys exclusive. Poly exclusion. Now the way I dey like call my own principle. That's the second one you suppose know. One is Aufbau principle. Call Aufbau principle, everybody, and call police exclusion principle. Now the third one, now wetin they call Hund's rule of maximum, Hund's rule of, some people dey put apostrophe S as Hund's rule of maximum multiplicity, maximum multiplicity. So if you no sabi these three chemical principles wey governs the arrangement of elements in an orbital, e don be for you o. E don be for you o. So make sure say this particular one, as I say make you call am, in fact for the last time everybody repeat after me. For the last time everybody repeat after me. Half-Ball's principle or something well na, keep your mouth well, call am well. Half-Ball, half-ball, half-ball principle. E don finish? Second one, Pauli's exclusion principle. Repeat after me now. Pauli's, call am well, comot mouth call am, you no dey disturb anybody. Pauli's exclusion principle. You don call am? The last one, Hund's rule of maximum multiplicity. Call am again. Hund's rule of maximum multiplicity. Oya repeat the three together. Repeat the three together, make we start with the half-ball principle. Call am again. Call the three again, make we start with the half-ball principle. Quick. All right. So let's move forward. Next, let's start with the half-ball principle. You're welcome. Welcome. Thank you for joining us. Next one, let's begin with the half-ball principle. Let's know what half-ball principle is all about. Let's know what the half-ball principle. Thank you for joining us. You're welcome. Thank you for joining us. Half-ball's principles. Half-ball's principle. Now, what is it about? When we talk about the half-ball principle, what is this half-ball principle about? What is it about? Wetin this half-ball principle? Wetin this half-ball principle dey talk about? It's very simple. Half-ball principle say electrons will occupy orbitals of lower energy level before that of higher energy level. I want to repeat. Half-ball principle say electrons will occupy orbitals of lower energy level before e go come dey occupy orbital of higher energy level. Make I write am down. Electrons will occupy orbitals of lower energy level before that of higher energy level. Simple. So may I continue? Make I continue. All right. You know, sir, they depend on our response before I continue. All right. So Harvard principle say electrons will occupy orbital of lower energy level before that of the higher energy level. What does this mean? Now, what are these orbitals we are talking about? Remember, we've defined what orbital is all about. So the question now is, what are these orbitals? Remember, we say orbitals is a region. We've defined it somewhere here. Orbital is a region in space where there is high possibility of finding an electron. So what are these? What are these orbitals? What are exactly these orbitals? What are these orbitals? Now, these are the orbitals. Anytime you are asked what are these orbitals, tell them it is the S, P, D, F. These are the orbitals. S, P, D, F. These are the orbitals we are talking about. S, P, D, F. Now, the question may come, even though sometimes we will not likely want to pay attention to this one. What does this S stands for? You must have heard of SPDF hybridized orbital, isn't it? You must have heard about SPDF hybridized orbital. SPDF, you must have been seeing SPDF in your textbook. Some of you don't know the full meaning of this SPDF. What does this S stands for? S stands for sharp. P stands for principal. Principal. D stands for what we call diffuse. Diffuse. And F stands for fundamental. 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 Somebody say, well done. Thank you so much. So that is what each of these things stands for. SPDF. S stands for sharp, P stands for principal, D stands for diffuse, F stands for fundamental. Now, this particular this shows the S orbital. This particular S shows the S orbital. And because it is the first one, it shows that it is the least energy level. This is the least energy level. This S is the least energy level compared to this particular P, D, and F. S is the least energy level compared to this particular P, D, and F. That means after S, which is the least energy level, the next one is the P, the next one is the D, and the next one is the F, as the case may be. Does that make sense? Does that make sense? Now, with this information you've gotten, what does this mean? It means that, maybe let me write this thing I said down so that some of you will know. You know what it means. This shows, I said this shows that S, S orbital have the least energy level compare to the P, D, and F, as the case may be. Therefore, therefore, what this means is that electron, remember we are talking about Aufbau principle. We are talking about Aufbau principle. I'm seeing somebody typing something like KLMN. That's not what I'm talking about. We are treating Aufbau principle. Follow the class sequentially. Somebody is mentioning KLMN. That is not what we are talking about. Follow the class sequentially. I know what I'm doing. So, therefore, electrons will occupy the S. Remember the law. Electrons will occupy orbitals of lower energy level before that of the higher energy level. And we say that the S is the orbital that have the least energy level compared to this other one. That means electrons will occupy the S orbital. It will occupy the S orbital first before the next. It will occupy the S orbital first before the next. As if that was not enough. How do we apply this particular one? How do we apply? Let me write it down. How do we? What is the actual application? What is the actual application of the Aufbau principle? What is the actual application of the Aufbau principle? Aufbau's principle. What is the actual application of the Aufbau principle? That is what I'm going to be showing you within 1 second. Let's go there. What is the actual application of the Aufbau principle? Let me show you the real application of this Aufbau principle in 1 second. Now, the application is quite simple, my guys. The actual application is pretty simple. What is that exactly? It's simple. Look at it. It actually governs writing the electronic configuration. A lot of you have heard about electronic configuration. Some of you don't even know how to do this electronic configuration. In today's class, you're going to learn electronic configuration. You're going to learn about electronic configuration of elements. You're going to learn the electronic configuration of elements. Some of you don't know how to write electronic configuration even up to today, and you're planning for exams. Today, your case will be settled. Make sure you keep sharing this live. If you've not hit the subscribe button, so that when I come live next time, you receive the notification. Remember that we have the orbitals to be S, P, D, F. Now look at how you're going to build that. It's quite very simple. I'm going to be having, let me use the black ink. I'm going to be having 1S. Of course, this is the list one, so I will start with 1S, 2S. Pay attention. 3S, 4S, 5S, 6S. I will stop at 7S. Then I will start with the next one, which will be for P, SP. It goes from the second line, 2P, 3P, 4P, 5P, 6P, 7P. Then I'll move to the next one. The next one is the D. So it comes from the next line, which is 3D, 4D, 5D, 6D, 7D. And then the last one, which is F, comes from the next line, which is 4F, 5F, 6F, 7F. Are you guys following? Okay. Now, the next one is, remember, this is a list. So you're going to start from this particular one. You're going to start from the S, meaning you have to talk about the S. You need to finish writing that of this S before we move to the next one. That's the meaning of this arrow. When you start with this particular S, you're done. You move to the 2S. When you're done, you have to start from this up, down, up, down, up, down. That means when I'm done with this, I need to focus on this before I can talk about this, talk about this, talk about this. I need to finish just like this. Look at how it's going. That's the indication of the arrow that if I'm done with this 3S, I need to consider 3P. After 3P, I don't need to talk about this one. After 3P, I have to talk about 4S before the next one. Look at it. Look at the movement. After this 4S, after this 3P, 4S, the next one I should be talking about is 3D. That's why the arrow is going like that. That's why you're seeing it drawn like this in your textbook. A lot of you have been saying this, but you don't know what it means. I think today you've known this particular one. So let me know in the comment section if this is the first time you're understanding this one. Let me know in the comment section if this is the first time you're understanding this one. If you know it already, also let me know in the comment section. All right. So this is the arrangement. Very, 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 very beautiful. Now when you don sabi how dem dey arrange this thing, how you wan take carry dey calculate the electronic configuration of element, how to use this thing, that's the next point now. How do you use, or may I use myself, how do I use this stuff wey I don do like this to write, how I wan use this thing take write, how I wan use this thing take write, how I wan use this thing take write the electronic configuration of elements. That's the big question. How we take use this one take write the electronic configuration of elements? My people, e dey very very simple. Make we do example 1. Example 1, we fit start with something like question 1, and the question say write the electronic configuration of sodium. That's the element we are starting with. Now, before we go answer this question, e get wetin I want make you note. Before we go answer this question, note these things. Note that S, you know that SPDF, S, the S orbital can only take 2 maximum electron. I mean, the maximum number of electrons wey the S orbital fit take na 2 o, e no go pass 2. E no go pass 2. E no go pass 2. The maximum number, remember I wan show you how to use this one, but this particular tips wey I dey give you now, na im go help you understand am. The maximum number of electrons wey S orbital go take na 2. E no go pass 2. Take note. Then the maximum, the p orbital takes 6 maximum electrons. The p orbital takes 6 maximum electrons. Now, this is a question for you guys. Who can tell me the d orbitals? Who can tell me about the d orbitals? What is the maximum electron the d orbital can take? Let me know in the comment section. The d orbital can take maximum of how many electrons? Yes? Somebody say 8. Is 8 correct? We are not doing 2, 4, 6, 8 oh. If you see 2, the next one will jump to 4. your mind should tell you that the next one should be 10. And if the first one is 2, the next one is 6, you should know that the difference is 4. So you ask yourself, what is different? What if you add 4 to 6? What will be the next number? That's 10. Now, okay, you can see that you can get the last one. Everybody will get the last one now. Everybody will get the last. If you add 4 to 10, what will be the one of F orbital? How many electrons can the F orbital take? The maximum. Who can tell me? Good, 14. That's brilliant. You can see that the difference between these things is just 4. Did you learn that one now? Have you learned that one now? That one don't enter. Notice the difference is just 4. The difference is just 4 because 6 minus 2 will give you 4. 10 minus 6 will give you 10 minus 6 will give you 4. 14 minus 10 will give you 4. Notice the difference is just 4. Have you learned that one now? Is that clear? All right. So the next thing we're going to be talking about right now is that question. Let's answer that particular question. That question says that we should write the electronic configuration of sodium. Write the electronic configuration of sodium. Now let's start with sodium. They say for sodium. What is the chemical symbol for sodium, everybody? What is the chemical symbol for sodium? What is the symbol for sodium? And I know Sabi that one. What's the chemical symbol for sodium, my people? S. How would you say S? Chemical symbol is 11. What is really happening? What is the meaning of the dot people are writing? What is going on? What is the meaning of that you're writing? What are you typing? So this is sodium. So now this is sodium. What is the atomic number of sodium? You ask yourself first, what is the atomic number and mass number of sodium? Now the atomic number for sodium is, let me put it like this. Sodium has its atomic number to be 11 and the mass number is 23. This one on the top is what we refer to as the mass number. And this one here, this one where we have here is what we refer to as the atomic number. So you can see something like this. You probably must have seen something like this in your, is it A that is somewhere here? And then what is here? Is it A that is in this position or A in this particular position? And what is here? Are you guys following me? Thank you. Somebody is just only somebody that is following me here. The question I'm asking is different. What people are saying is also different. So I was asking this Z, is it supposed to be top or supposed to be down? And people are typing something different. All right, so let's move forward. Let's move forward. I want to explain something before we start doing the electronic configuration. You guys are not responding. Can I continue? There's something I want you guys to note. For a neutral atom, for a neutral atom, atomic number is also called proton number. It's also called proton number. Not only that, also it's also called electron number. Please pen this down. This is very important. I want to use it to like talk about this sodium right now. Take that down. Are you there? Hi, welcome. Thank you for joining us. Can I proceed? Okay, somebody said noted. Let me proceed. So notice that sodium has no charge. This sodium, it has no charge. You know that kind of element where you write maybe chlorine and then you're putting charge and all of those things. Sodium has no charge. So it is called a neutral atom. Now, because sodium is a neutral atom, if it has a charge, it will be called a charged atom. Listen, no, if it has a charge, it should have been called a charged atom. Therefore, because it's a neutral charge, it is called a neutral atom. Now, because it's a neutral atom, 11, which is the atomic number, is also going to be the proton number, which is also going to be the electron number. You can see from there we have electron number, electronic configuration, electron number. Does that make sense? Does that make sense? So now to write the electronic configuration, we will use the electron number, which is this particular one, which is this one. That's what we're going to be using for the electron number. So let's start. The electronic configuration for sodium is going to be, remember this electron number is what we're going to be using. So we have 1s. Let's use this stuff. Let's use this stuff. It's going to be 1s. Remember, I start with 1s. 1s. Oh, I don't know how I can be able to share this thing so that two of them will be showing. Let me keep it like this. Can it work like this? No. What should I do? I just want to balance so that this thing will be showing. Okay, can we see it like this now? Remember, 1s is the first one. I'll write 1s. Then ask yourself, where is that 2 they usually write on top? Where is that one coming from? That's why I said the maximum electrons, the maximum electron. Look at this place. Look at this particular point. S orbital takes 2 maximum electrons. It doesn't take anything more than 2. It takes 2 maximum. So that's why you're seeing S1, S2. This 2 is because we want to count until we get to 11. When we get to 11, I mean the one on top is the one we are counting on, not all this one, all these things. This one is just the numbering. Then when you're done with this, move to the next one, which is 2s. 2s, 2, because s takes maximum. Remember, we have gotten 4. Move to the next one, which is this particular 2p. 2p, remember, p takes maximum of how many? Let me ask you that one. Let me not show you. How many? What is the maximum electron that p takes? Everybody, let's go. Talk, be smart. Talk. Don't pass the answer. We are not asking you the answer. We are teaching people who don't know. If you know it, keep it to yourself. If I ask you the answer, then you talk. If I give you another element to try, you do it. That's how you stay organized in a live class like this, because we want to carry everybody along. We are not showing off right now. We are teaching. We are training people who don't know. So exercise patient. Don't make them feel bad. Don't make them feel bad. Exercise patient for them to learn. Okay, we know you know it already. If I come up with another topic that you don't know, to you keep quiet. You wouldn't want to rush like that. So just keep that serene very clean so that people will enjoy the lesson. Is that okay? And if I ask you to drop your answer, you should do that. So yes, maximum you can take is 6. It's not compulsory that you must write 6. So depending on the element you're working on, remember we are looking for 11. This is 2, 4 plus 6. That's 10. So maybe you're looking for element that has the atomic number to be 8. I think we shouldn't have even used 6. If we have gotten to 4 and we needed 4, we would have put this P should have carried 4. That means we just need 4 to complete this one to make it 8. So, but then we are saying that it can't exceed this particular. You know, if you pass 6, go up again. Maximum waste P fit take na 6. This talk what I talk now, he enter, my guys. Talk to me. He enter. So in that case, the next one after P on this point is this 3s. 3s, remember that the maximum s can take is 2. But if you put 2 now, if you can, 2, 4, 6. 2, 4 plus 6. 2 plus 2 is 4. Plus 6 is 10. We just need only 1 to give us 11. We don't need up to 2. Even though we know the maximum you can take is 2, but it cannot exceed 2. That means we have 2, 2, 6, 1. So this gives us 11. 2, 2, 6, 1. Add it together gives you 11. So this shows the electronic configuration for sodium. Does that make sense? Classwork. Write the electronic configuration of aluminum, which is Al. From what you've learned, try that out. I gave a classwork. I'm waiting for the answer. I say you should write the electronic configuration of aluminum. You are typing 13. I'm not asking for atomic number, atomic mass. Solve it step by step. Carry your pen and your paper. Solve it, and then the answer, you type it out. Even if I want to do the solution, I'm going to be doing that together with you guys. Oh, it is 10 o'clock. The time has passed. I think the class should be over right now. I think I have delivered the work that brought me. In the next class, I'll be talking about polar exclusion principle and Hund's rule of maximum multiplicity. Then after that, the next class will be on quantum number. If I'm done with quantum number, we'll move also to the next one, which will be I think we've treated everything about oxidation number. I've done a lot. I think I finished everything about oxidation number. Maybe I'll just do redox reaction the next one. And after that, we do stoichiometry. We'll talk about the concept of mole. So, but for now, that is all I have for you. And I hope you will share this particular video after now. I hope you're also going to save this particular video. I hope you're going to also like this video and let me know in the comment section if this video and this section today was helpful. Please make sure to hit the subscribe button. Make sure to turn on the bell icon close to the subscription button so that when I come live next one, you definitely receive notification. Until next time, I'm going to see you. But before I leave, let's do the solution to this particular problem. If you're set, then let's go. Please, the next live stream is going to be by Saturday. On Saturday, we're going to be coming live again. So the atomic number for this particular aluminum is 13 and the mass number is 27. We don't have any interest on the mass number. It's atomic number. So that means we have 1s2. The next one, is going to be 2s2. The next one is 2p6. That means this is 10. We just need 3. Next one is going to be 3s2. Then the next one is 3p1. Was this your answer? Was this your answer? The next class is going to be on Saturday. Please don't forget, same time. Make sure to share my channel to other of your colleagues. Let them know about my channel because If I'm coming live, I want to see a lot of you coming to learn from me because I'm going to make sure I deliver my best. Thank you so much for participating. Thank you so much for sharing the live. Thank you for being with me. I appreciate you guys all. God bless you. God bless you. And congratulations for having this answer correctly. That means I think you really enjoyed today's section. My name is Mr. Alison, and until next time, I'm going to see you. Bye bye.